Chemistry example. A chemical reaction results in the formation of one or more substances called products from one or more starting materials called reactants. For instance, 2H2 plus O2 is twice H2O, the water molecule. So these are the reactants. This is the product. Okay. Two molecules of hydrogen and one molecule of oxygen form two molecules of water. Okay. So this is the product. These are the reactants. So consider the reaction. A plus B produces to product C. So here are the reactants. C is the product. This process is called reaction. All right. The concentration of a reactant A is number of moles. What is a mole? 1 mole is 6.022 times 10 to the 23 number of molecules. Okay. So unit concentration is number of moles, number of molecules, these many molecules per liter. So what is concentration? Number of moles per liter and is denoted by bracket A. Bracket A stands for concentration. The concentration varies, that is changes during a reaction. So the concentration of A, concentration of B, concentration of C are all functions of time t. The average rate of reaction of the product C over time interval. So average rate of reaction is delta of the concentration of C over delta of time. So that is concentration of C at time t2 minus concentration of C at time t1 over. So this is what we would call slope of the secant. Now that is average rate of reaction. Now when we are talking about instantaneous rate of reaction, you are going to take limit delta t going to 0, delta of the concentration of C over delta t. So this is denoted by dC dt, d concentration C. So concentration of the product increases as the reaction proceeds. The derivative will be positive. So the rate of reaction of C is positive. Okay, so as the reaction continues, notice you are going to have more product basically. So this derivative will be positive always. Well, concentrations of the reactants A and B, right, they will decrease during the reaction. So these rates will be negative. All right. So rate of reaction, so notice the reactants A and B, they will decrease at the same rate that C increases, you see. So rate of reaction, that is D of the concentration C with respect to T, is negative dA concentration A with respect to time, which is same as negative D of the concentration of B with respect to time. Now number of moles, yeah, A, so this is the molecule. So suppose you have a reaction of the form little a capital A plus little b capital B. So this results, so the products are C and D. In this case, we have negative, you have to divide by 1 over A for the concentration of A, rate of change of A with respect to time. That will be equal negative. So as A reduces, C increases, D increases. Likewise, as B reduces, C. So in one reaction, the left hand side, each reactant reduces at the same rate as each product increases. Yeah, concentration increases at the same rate. So you see 1 over C and 1 over D. The rate of reaction can be determined from data and graphical methods. Some cases there are explicit formulas for the concentrations as functions of time, which enable us to compute the rate of reaction. All right. So the next example is on thermodynamics. That is one of the quantities of interest in thermodynamics is compressibility. If a given substance is kept at constant temperature, then its volume V depends on its pressure P. So rate of change of volume with respect to pressure dV by dP. Okay, as P increases, V decreases. So you see, as pressure increases, volume decreases. You can understand, right? So if you take a sponge, if you press on it, the volume decreases. That's all you're saying. So dV dP is negative. The compressibility is defined by introducing a negative, a minus sign, and dividing this by the. So isothermal compressibility, it's denoted by Greek letter beta, that is negative 1 over V dV by dP. Okay. Beta measures how fast per unit volume the volume of a substance decreases, okay, as the pressure on it increases. For instance, if the volume V of a sample of air at 25 degrees centigrade was found to be related to the pressure P, P is measured in kilopascals by the equation. V is 5.3 over P. All right. dV by dP is negative. So we used that particular um, formula, and now you are going to find the derivative of V with respect to P. So you get this. When P is 50 kilopascals, you just implement that, right? So you get dV dP is such meter cubed per kilopascal. So beta, which is compressibility, it is negative 1 over V dV dP at the given point. So you are simply substituting the value. Okay, V is this. All right, so that is your answer. Biology, well, you see, in biology there are many more examples, so I'll come to biology in my next video. Until then.